All right, so here we are again in my bathroom for fear of making a mess with the experiment today if it doesn't work. So today what we are doing is we are making a fireproof balloon, which is between chemistry and balloons popping. I'm facing two of my biggest fears in one fun video, so here we go. So what I have here are, I've actually got a packet of balloons just in case I needed more. I have some water in an easy to pour bottle so that I can get it into the mouth of the balloon. And I have my large extended lighter like was used in the video. That was the example. So what I am going to do is I am going to start with a balloon that's full of air so that we can see what happens when there's no water in the balloon versus when there's water. So this is really going to be quite challenging for me. I'm going to try to plug one of my ears while I do this because I know what's going to happen. So I'm going to hold this like this. So that's what happens when there's no water in the balloon. I actually don't know where that went, so I'll be finding that later. And then when I take the water and I pour it into this balloon, so what I'm going to do is just, you can smell the burning latex. I hope that's not causing a problem somewhere. I'm just going to flip the water into the balloon like such, fill it up. This is what we used to do when I was a camp counselor. Suction is trying to pull it back into the water bottle. It's not part of the plan. There we go. Saved my water bottle. And then I'm going to let a little bit out, and then I'm going to blow the rest up. I'm going to tie it off. Ooh. It's a little bit trickier to tie them when it was full of air. Alright, so there's my balloon with water in it. And I'm going to take my lighter. And look at that. Not popping. What you can see though is there is some soot on the bottom. And I am, holding the flame low. I'm actually touching the balloon with the lighter, and it's not popping. And so what we can see is that obviously this balloon did not pop like the first one, and that is because, and we can also see that there's, I got it all over my hands, the formation of soot on the bottom of this balloon, which is different obviously from the other one that popped. And what's happening here is that the balloon is so thin that it's allowing the water to absorb the heat from the lighter. So it's acting almost as like this super thin membrane that's transferring the energy from the lighter to the water and not directly to the super thin latex of the balloon. And inside the balloon, when the water is heating up, it's being displaced by cooler water that is at the base of the balloon. And the cooler water is then turning to the warm water, and the cycle repeats. And this is repeating itself so often that the balloon is actually kept from popping. So by that lighter being down here, the water that's at the base of the balloon heating up is becoming a cycle. So as that water heats up, it travels to the top of the balloon, and there's cooler water all of a sudden at the bottom. As that water from the bottom then makes its way back up to the top, this water that was at the top of the balloon, because it's no longer exposed to the lighter and the direct flame, it's losing that heat. It's losing some of that energy. So it's able to cool back down and then repeat the cycle. And this will occur until the heat of the flame is greater than the water's ability to conduct the heat. And so that means if the flame was big enough or strong enough that that water process wasn't having enough time to get to the bottom and cool, or get to the top and cool, that the cycle, there would be warm water in here and there would be nowhere to displace that energy from the lighter. Thus, the balloon would pop just like in the first example, but making a way bigger mess than that first balloon. So, really cool experiment. Really hate balloons popping, but that's it for this week.